Unit 1A, page 1, test review solutions. To evaluate an expression, what order of operations do you follow? We always follow the same order of operations. We solve inside the parentheses first, then we expand all our exponents, then we do division and multiplication as it appears in order from left to right, and finally we do subtraction and addition in order from left to right. I think what they really are asking us is, how do we evaluate an expression? Well, first, combine like terms. Remember, we cannot combine terms that are not alike. Second, we can simplify the expression sometimes. When they say evaluate an expression, they are giving us the information that someone is telling us some values to use. So third, we will substitute the given values. And finally, we will find the simplest answer. So, order of operations is just order of operations. To evaluate an expression, we combine like terms, we simplify the expression, we substitute given values. We know we can do this because they are saying that we must evaluate this expression, and then we find the simplest answer. To solve an equation where x is added to another number, you subtract that number from both sides. And remember, it has to be from both sides. If you subtract a quantity from only one side, you are changing the relationship from an equation to an inequality, and we just can't do that. To solve an equation where x is divided by another number, you multiply both sides by that number. If x appears as the numerator of a fraction, x over 2, then of course we multiply both sides by 2. Now, to solve an equation with x on both sides of the equal sign, you subtract the x term. You subtract the same x term from both sides. So if you have 4x on one side and 2x on the other side, you must either subtract 2x from both sides or subtract 4x from both sides. To check your solution to an equation, you substitute your answer into the original equation. Hold on here, we are almost done. Give an example that illustrates the distributive property. 4 times 2x squared plus 5, or x times 2x plus 3. This coefficient is multiplied to this term, then it's multiplied to the other term. This times this plus this times this. So 4 times 2x squared is 8x squared. 4 times plus 5 is 20. X times 2x is 2x squared. X times 3 is just plus 3x. Give one example and one non-example of like terms. Okay, here we have an example that illustrates the distributive property. 4 times 2x squared plus 5. Here would be your answer. Another example, x times 2x plus 3. The x distributes to each term. An example and a non-example of like terms. An example would be 4x squared minus 2x squared plus 8x squared. These are all like terms, the same variable raised to the same exponent. A non-example would be 5y squared plus 5y plus 5. We have the same variable, but this one is raised to an exponent. This has a different exponent, and this one has an exponent of 0, which makes it 1. An example of like terms, a non-example of like terms. True or false? In order for two terms to be considered alike, they must have the same coefficient. The coefficient is the multiplier. So, if we have 3x squared and 3z, they have the same coefficient, but they do not have the same variable, and they do not have the same exponent. In order for two terms to be considered alike, we must have like terms have the same variable raised to the same exponent. So, this is clearly false, and this is why. Thank you for your kind attention.